Welcome back to the channel. In this lesson, we'll see how to evaluate inverse hyperbolic functions. In our last lessons, I explained how to evaluate hyperbolic functions themselves, and also we explained the graphs of hyperbolic functions. In case you missed those lessons, please do not hesitate to check the description below. Also, as a prerequisite to this lesson, you need to understand quadratic equations. In case you miss our lessons on quadratic equations, we'll place a link in our description and also a link up here to help you access our lesson on quadratic equations. That said, let's get into class. Now, here's going to be the first example we will take for this lesson. At the end of this lesson, I will also give you a take-home example that you can solve on your own. I will appreciate if you solve that example and share your results with us in the comment section. Okay, now our first example says we should find the sine inverse of 1.475. Now, in our previous lessons, we said if sine x, we said is equals to e raised to power x minus e raised to power minus x over 2. Now, if the whole of this expression is equals to 1.475, that means e raised to power x minus e raised to power minus x over 2 is equals to 1.475. Now we can cross multiply. My e raised to power x now minus e raised to power minus x with the same thing as 2 into 1.475. Now, so that my e raised to power x minus e raised to power minus x with the same thing as 2.950 from my calculator. Now with this, if you look at this expression carefully, I have e raised to power minus x and I also have e raised to power x. In evaluating hyperbolic functions, there are two ways we can go about it. I can either try and resolve this into a quadratic equation or resolve it to using logarithms. But for this, I'll use quadratic equation, and in our next lesson, I'll solve using logarithms. Now, the first thing I want to do to resolve this into a quadratic equation is I'll multiply through by e raised to power x. Now, we're multiplying through, or you say you multiply both sides by e raised to power x. That if I multiply both sides by e raised to power x, this becomes e raised to power x into e raised to power x minus x is equals to 2.950 e raised to power x. Now, e raised to power x multiplying e raised to power x, it becomes e raised to power x all squared. Minus, if you look at this carefully, e raised to power x times e raised to power minus x. This is as good as saying a times 1 over a. A here is 1, a here is 1. The expression becomes 1. So this becomes minus 1 is equals to 2.950 e raised to power x. Now, I want to collect like terms. I want to bring 2.950 to the other side. So it's going to become negative. This becomes e raised to power x all squared minus 2.950 e raised to power x minus 1 equals 0. Now, I have e raised to power x repeating itself twice, and I have 1 to the power of 2. I can form that conveniently into a quadratic equation by saying let k equals e raised to power x. So that this becomes a raised to power 2 minus 2.950 a minus 1 is equals to 0. I believe this is beginning to look like the conventional quadratic equation. To solve this, because I have 2.950k, I'll not be using factorization method. I'll simply use the formula. Now, let's open another page to get started. Now, I'll solve this with factorization method. The first thing, remember that factorization method says that x is equals to minus b plus or minus square root of b squared minus 4ac over 2a. Now from here, my b obviously is the same thing as minus 2.950. My a is the same thing as 1. And my c is the same thing as minus 1. So that my k now, or my x rather, will be the same thing, or k, because I've used k in here, will be the same thing as 2, will be the same thing as minus into minus 2.950 plus and minus, plus or minus square root of 2.950 all squared. I can throw away the negative sign because of the square, minus 4 into minus 1, everything over 2a. That's 2 into 1. So that my k from this expression will be the same thing as 2.950 plus and plus or minus the square root of 2.950 times 2.950. Obviously, that's 8.7 from my calculator, 8.702 plus 4 over 2. So that k now will be the same thing as 2.950 plus plus or minus the square root of 12.702 over 2. Now, clearly, k is the same thing as 2.950 plus or minus square root of 12.7, that's 3.5 from my calculator, 3.564 over 2. So that k now is the same thing as 2.950 plus 3.564 over 2, or 2.950 minus 3.564 over 2. So that my k is equals to 2.950 plus 3.64 from my calculator. That's the same thing as 6.514 over 2, or negative 0.614 over 2. So that k will be the same thing as 3.257 or minus 0.307. Now remember, we said we took an assumption that k, that e raised to power x, is the same thing as k. That is, e raised to power x will be the same thing as 3.257. Now, I'm not going to consider this any longer because of the negative sign. So I'm leaving the minus 0.307 because it's not real. This is where I'll get real numbers. So that e raised to power x, if e raised to power x is the same thing as 3.257, then x now will be the same thing as the ln of 3.257. So that my x is equals to 1.1789 from my calculator. Now, with this, you've seen, with this, we've come to the end of the first example. Like I did promise earlier, I would leave you with a take-home example. You can try your hand on this and share your results with us in the comment section. Thank you for staying with us, and see you in our next class.